This is the third and the final lesson on the basis of the Loki cam. We want to move our focus now to the construction of the cam disk profile. So let's identify what we see on the page here. So firstly, we identify the wedged-ended follower. That is the type of follower that we need to use in this specific construction. We identify then the turn of our camshaft, which is in this case anti-clockwise. We will then immediately make sure that we go and label our construction in the opposite direction as that of the turn of the camshaft. We also see that we have now divided our whole cam disk profile into 12 equal segments of 30 degrees each. So this is very important that we have gone through the center of our camshaft and drew those 30 and 60 degree construction lines right through the center to divide the full 360 degrees into intervals of 30 degrees, which will give us 12 equal segments. And then we also make sure that we know where our minimum displacement is, which is from the center of the camshaft to the lowest end of, in this case, the wedged-ended follower. Also remember, we have the knife-edged follower is the other term that they use for this type of follower. And then we also make sure that we always go and draw in the camshaft diameter and that we hatch that camshaft at an angle of 45 degrees. Once we've done that, we also normally go and draw a full light construction circle all the way around in the 360 degrees to identify the maximum displacement of our movement of the follower. So that's our maximum displacement. Please indicate that full construction circle. And then we will determine now through construction all the heights that come from our displacement graph. So all of these heights that are projected from the graph onto the vertical center line of our cam disk profile. So these projections of the different height intervals must meet up with this vertical center line. And then we will take our compass, place it at the center point of the cam disk itself or the cam shaft, and we will then stretch our compass then to each of these different height intervals and project them accordingly to the 30-degree intervals at each of those different heights. We are going to focus our attention now on the tip of the wedged-ended follower, and the tip of the wedged-ended follower is at the minimum displacement, meaning that's the lowest that the follower can fall in this movement. It is at 0 degrees, which is then the starting position of the movement throughout the 360 degrees. And then we're going to draw a light construction line now from the minimum displacement where our wedged-ended follower is starting its movement out to the displacement graph. And this will be then also the lowest position of the follower indicated in our displacement graph. We also refer to the minimum displacement of the tip of our follower here as the trace point. And we also have constructed a full construction circle all around at the displacement of our follower at its minimum, so referring to the minimum displacement. I always require this to be drawn in as well, and then we always hatch our cam shaft as well. And then we make sure that our center lines are also drawn in properly. And lastly, we must show the turn of our camshaft by indicating it with an arrow, in this case anti-clockwise. With the same scenario, but in this case we now have a roller-ended follower, we see that we are focusing on the center point of the roller follower. So the same rules and projections and constructions apply, except for now we are not working with the tip of a wedged-ended follower. We are working from the center point of the circle for our roller follower, Therefore, our projection from the center of the roller follower is going to go out to our displacement graph, and that will serve as the minimum displacement of the roller follower on our graph of displacement. Here is a breakdown of the construction of our cam disk profile. We have already drawn in the center lines, the horizontal and vertical center lines. We have already drawn in our cam shaft and hatched it. We've also drawn in the direction of rotation of the cam shaft. We have also drawn in the minimum displacement indicated by this red circle here, and we've already drawn in our follower, and then from the minimum displacement we've also drawn in that baseline for the graph of displacement, and we also have labeled now in the opposite direction to that of the turn of the camshaft our 30, 60 and 90 degree and so on intervals, and we've labeled them properly on the outer edge of our construction. But we also now have taken our 30 and 60 degree set square, and through the center of the camshaft I've drawn in those 30 and 60 degree intervals that represent the 12 segments of movement for our follower. As mentioned in my previous videos, I always ask the students to draw in the full construction circle for the maximum displacement all around, and then we also have indicated the minimum displacement and the line going out as a baseline for our graph of displacement, as well as projected out the height of our maximum displacement to our graph of displacement. This is just a basic illustration of mine to indicate the position of the follower at each one of the 30 degree intervals on our graph of displacement, and here it is then easy to see where the follower's tip would be positioned at what height at each one of these intervals, and we will then project those heights to the center line of our cam disk profile. Let's take a look at the different features of our graph of displacement. We have our heading for the movement, which is the uniform motion. Therefore, we know that all of our graph's lines are going to be straight lines, and that solid straight line will represent then the uniform motion of our follower, and that throughout the 360 degrees. We must label the graph as a graph displacement graph or a graph of displacement. We have our scale, which was also we indicated, in this case each 10 millimeters equals 30 degrees, so therefore we know that there is 10 millimeters between each one of these 30 degree intervals on our graph displacement. So we definitely would go and say that 10 times 12, meaning that from 0 to 360 degrees would give us 120 millimeters in total. And we also have indicated here where it rise, where it dwell, and where it fall. So that is the movement of our follower. And what we also want to make sure of is that we see that our heights that are project now from each one of these intervals where it cuts on each of the 30 degree segments, that those heights are all going to be projected now to the vertical center line of our cam disk profile. Once we've sorted out all the details on our graph of displacement, we have projected those heights from our reference points on the graph of displacement to our vertical center line on the cam disk profile. We now are going to make sure that we correlate each one of the degrees, the 30 degree intervals as indicated on our graph of displacement, and we're going to correlate that with our cam disk profile's construction. In this case, our cam shaft is turning anti-clockwise, so therefore our projections is going to be in the opposite direction of that, and that is why we're going to make sure now that we place our compass at the center of the cam shaft, and we're going to look at our graph of displacement simultaneously. And on the graph of displacement we see that at 30 degrees this is our height, and what we want to do is project that height all the way to the vertical center line, and from that vertical center line is where we're going to place our compass now. And as we have mentioned, from the center point of our camshaft to that height now, and we're going to go and project an arc onto the 30 degree interval, which is the first 30 segments 30-degree segments that we now have on our cam disk profile. And so we will then consecutively move from one 30-degree interval to the next. So if we just look at the 60 degrees, we are going to say from 60 degrees, that height is projected to the vertical center line. And then from there, we are going to project it now to 60 degrees. And that would then be the height displacement of our follower at 60 degrees. And so we just carry on all the way. I'm not going to do all of them, but from 90 degrees, we see it's reached its maximum displacement. So on the maximum displacement, it's going to be projected now all the way all around to 90 degrees. And we also know that it is going to dwell now at 120 and 150 degrees. So we know that that projection is going to go 120 to 150, all at the maximum displacement is where it's going to dwell. And when that is done, we are going to move on now to 180 degrees and so on, till we have now completed all of these different segments heights on our cam disk profiles construction at each one of these 12 intervals. And once we have that, we are ready to do the cam disk profiles full construction curve. Let's take the same graph of displacement example, but replace the wedged ended follower with a roller ended follower. And as you can see here, that our center point of our roller ended follower is aligned with the base of our graph of displacement and vice versa. Therefore, at the graph of displacement, I've now placed 4 followers as an example, just to indicate where the center point of that roller follower is going to be the height distribution that we project all the way to the vertical center line. So at each one of the 30-degree intervals of our graph of displacement, it is the center point of the roller that we're going to use that height and project it to our vertical center line on the cam disk profile. And then on the cam disk profile, as we have done with the previous example, we again take our compass and we're going to place it at the center of the camshaft and then stretch it now to the appropriate height. So if we were to take 30 degrees height now, the projection coming from the displacement graph, we are going to use the center point of that circle and we're going to project that center point to the 30-degree interval. The same with the 60-degree interval, and then also the same with our 90-degree interval. Let's get our attention back to the wedge-ended follower, and we are going to double check that our projections are done correctly from the heights that are projected from the graph of displacement onto our vertical center line. And we're going to start with 0 degrees where the minimum displacement is, then move on to the 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 350 degrees back to 0 degrees or the full rotation of 360 degrees. So those reference points we clearly indicate with the wedge-ended follower. You can, with the roller-ended follower, go and draw with your circle stencil now the size of your roller at each one of those reference points around the reference point to indicate the roller itself. And with the wedge-ended follower, we just have these reference points. Finally, we can now draw in the actual cam disk profile. This is the dark solid outline on our constructions that we have been doing all the way. So from here, we are just going to use our French curve. And with the French curve, we are just going to go and connect each one of these reference points one after the other. I usually line up them about 3 points on the French curve. That will give me the nice curve where it dwells. We can just use our compass from the center of the camshaft because that's just one constant radius. But when it starts falling again from 150 degrees all the way around, it's going to continue to fall past 270, past 300, past 330, all the way back to 360 degrees / 0 degrees. That will give us the dark solid outline of our cam disk profile. Now these count a few marks, so make sure that you draw it in neat proper with your French curve. I know sometimes they allow you to do this freehand, but I would definitely deter you from doing that unless you are very well versed in drawing freehand, but preferably make use of your French curve. That is what the tool is for, and it definitely will get the job done well. Thank you. Here is the final product of our complete construction, all the projections taken from our graph of displacement to our cam disk profile, and then we have added all the labels, we have done the cam disk profiles outline, we've done the hatching, the direction. So our final checklist, we just go through it, make sure all of the work is done, but well done. This is the complete construction of this wedge-ended follower on this particular example from the old JPEGD workbook, the 2016 version of page 105. Once again, we just want to thank TurboCAD Africa and JPEGD, as well as the online school for all the hard work that they do.